All right, guys, so we're going to get started. I see some people are introducing themselves in the chat. Welcome. We're so glad that you can be here with us today. We have a long discussion ahead of us. We have a big panel here with some very distinguished speakers, so I'm looking forward to the discussion. We're here today to discuss the future challenges of IoT, together with Hub Security's very own CRO, David Hochhauser, along with a number of IoT and security experts, including Erik, Varney, Rajiv, Kalamdani, Dr. Guru Prasad, Farid, Monemi, Bichareh. Excuse me if I'm pronouncing any of these names incorrectly. Anup Mohan and Ilya Bidig. Thank you guys so much for being here today.
Thanks.
So we're going to start our webinar with a brief introduction from David Hochhauser on the security challenges related to industrial IoT. And then our panelists will each get the chance to briefly introduce themselves. Afterwards, we'll get into a bit of a deeper discussion on everything related to IoT challenges, threats, and solutions, and how to address them. As usual, we'll leave about 30 minutes at the end of our discussion for a short Q&A. So if you have any questions throughout the discussion, you can drop them in the Q&A section below, and we will get to them later on. You can also write them in the chat. If you can't find the Q&A, that's okay too. Now we have a very impressive lineup of panelists here tonight, and I'm excited to have, or today for some of you, I'm excited to have them introduce themselves. But first we'll begin with a few words from David before we hand off the mic for introductions. Take it away, David.
Okay, good. Hey, thanks, Sterling. So I'm Dave Hochhauser, and as you mentioned, I'm Chief Revenue Officer for Hub Security. And for those who don't know, we are design extremely secure cybersecurity solutions and computing platforms. We design our own hardware and software around that. So first of all, welcome to what I think will be a fascinating discussion. And I just wanted to take a minute or two just to explain kind of why we're holding this session on industrial IoT. And then we'll get most of the session focused on our expert guests, who are actually, it's a pretty impressive panel, and I'm really looking forward to listening to them. So when you might have heard the term the fourth industrial revolution, or more shortly IR 4.0. So we really are kind of in the middle of a revolutionary era of innovation in this whole industrial section. And it's kind of driven by all of these autonomous smart, quote, things, fueled by tons of data. And so we're doing things like remote, monitoring, predictive maintenance, automation, production, and more even without people. So these things is really what we call IoT. And the other related to that is their digital twins. And they're making kind of the simulations and the control very, very efficient. The interesting fact is, while this whole thing has kind of been underway for a while, I think actually the pandemic is kind of accelerating this whole thing. Notice all the supply chain problems that, that are going on. So it's really increased the pace of moving all the production back to the domestic locations. So in a sense, everybody's starting to make their own things again, and we're heading in that direction. And one other point, we think of industrial, IR 4.0 about manufacturing. In a sense, I think of it, it's actually part of a broader category called critical infrastructure. And you hear about critical infrastructure all the time, and it's really many, many industries. Critical infrastructure is everything from manufacturing through water systems and supplies, electric utilities and its distribution. You have oil and gas distribution. In the US alone, there are over 2 million farms in the US that's really part of the critical infrastructure and its whole entire supply chain and food production facilities. Mass transit systems, smart cities, all of this stuff is part of what we'll say is, kind of critical infrastructure in this whole industrial revolution. So the thing that I think you'll hear quite a bit today is a lot of the challenges. And a particular area I focus on is dealing with cybersecurity. And what you'll find is a lot of these environments, they're sitting outside traditional IT. So they make them really susceptible to attacks. So if you take like the Florida water supply, which they try to attack, you have remote facilities and somebody's coming in there and trying to change the chemical composition of water that's going in there. So you could have, arsenic, and all of a sudden what should be, a millionth of a particle, somebody says, hey, let's make that, 100 particles per gallon. And before you know it, you're poisoning the population. You've seen the Colonial Pipeline, how that shuts things down. So there's an interesting thing about this. It's not only kind of cybersecurity traditionally, hey, it's a breach and it creates a risk for the company. It's actually a national security risk as well. And it's why you're seeing a lot of this stuff getting funded both by the government and its private enterprise as well. So why, to add to that, actually, the pace of the change and stuff and the challenge is growing at a phenomenal pace. And, one last point, I'll just give you an idea. Just one piece of this deals with edge computing quite a bit. That's going to be by IDC a $250 billion market in the next 2 years. And you'll also hear from the discussion, a lot of this is around AI as well, is very heavily involved in AI and the automation and monitoring. That is projected to be $267 billion industry by 2027, which is a 10-fold increase from just 2 years ago. The third factor that I put on top of that is cybersecurity around all of this. And the estimates are just skyrocketing. Just alone the other day, I heard there are literally about 3 million job openings in cybersecurity worldwide currently. So there's a ton of, you put this together and the challenge is just enormous. So in summary, that's kind of why we felt, industrial IoT as a whole really deserves, some attention, and we've grouped together a great group of people to go through this, and we'll break it kind of in 3 sections. One will kind of give you an overview. Everybody has their definition of industrial IoT, what the market is, their use cases. Then we'll spend a considerable time on some of the challenges around it, whether deploying it, developing it, compliance, regulations, security around there. And lastly, some of the trends, where all the people actually see things, heading. What are some of the solutions and what are some of the trends that people are looking at? So with that, hopefully you've got at least a decent idea of, why we're pulling this together from a security company perspective on industrial and IoT as a whole. So I hope you enjoy listening to the panel and sit back and enjoy.
Yeah,
Thanks.
Thank you, David. Yeah, we're really glad that you could join us today. I always enjoy hosting with you. Yeah, we haven't done it in some time, so welcome. Now I'd like to just take a few minutes to do a quick introduction round. Maybe we can start with Erik. Would you mind giving our listeners a bit of background on yourself and your field of expertise?
Absolutely. So Erik Varney, Managing Director of Telematics and Industrial IoT for Verizon. Been with Verizon just over 18 years and have been doing IoT with them for the last 10 of those 18 and have been doing quite a bit in this space and really excited to talk today about what Verizon Wireless does from a security standpoint, but ensuring that we have the next generation of industrial IoT solutions available to those that are really wanting to take advantage of them immediately.
Awesome. Really glad you could be here with us, Erik. Next, Rajiv from Ford Motor Company.
Hi, hello. So good morning, good evening, everybody. So my name is Rajeev Kalamdani. I am my title is Manager of IoT Analytics at Ford Motor Company. So we've got a group entitled GDI&A, which is Global Data Insights Analytics, that supports all the different skill teams within the company, of which I'm a part of, and I support the manufacturing. So we have about 80 plants globally, Asia, Europe, North America, etc. And we also have a lot of engineering organizations. So we've got a massive undertaking on getting all our factories modernized, especially with IoT. So my role is to help with deploying machine learning use cases and AI-based use cases, and in some cases just pure visualization. Right? So, and I've got background in manufacturing, right from working on the shop floor all the way to engineering and so on. Right. So that's me. Thanks.
Awesome. Thanks for joining us. Next, we have Dr. Guru from Bosch Engineering.
Hello, everybody. I'm Dr. Prasad. My specialization is around sensors and IoT. So I come from Bangalore. Presently, I'm responsible for putting up a right strategy for two topics, which are very, very important for future of Bosch. One is around sensors. Second one is around edge IoT. David was very clearly mentioning IoT is taking a complete radical shift in terms of what applications it was actually trying to address. And probably next few years, it has to look into completely different set of applications which are right now not possible in the existing framework of IoT. So my responsibility in Bosch is to ensure that we build right competencies, we strike right partnerships with right companies to ensure that we become an engineering technical partner for IoT ecosystem. Thank you all, and looking forward to hear from you.
Thank you, Dr. Prasad. Next, we have Farid, who is joining us from Stiles Machinery.
Hi, I just make a correction. I'm sitting here at ASA, not Stiles Machinery, but that's okay. Also, I'm the chair of Smart, no problem. Chair of the Smart Factory at the Industrial IoT Consortium, and also a member of the steering committee at the Industrial IoT Consortium, more than 22 years in manufacturing and innovative technology, specifically focused on IoT interoperability challenges of connectivity as well, working on concepts of like 6G and beyond that, and also have been in many of digital transformation committee of several corporates. I think that will be it.
Great. Well, thanks for being here today. And next we have Mohan from Google Cloud.
Hi there, thank you for having me here. Good morning, good evening, wherever you are across the world. This is Anup here, a product and a technologist, been across multiple different companies working on IoT, Cisco, Comcast, Samsung, Rockwell, and very recently actually just joined Google. I've seen across various different verticals, from consumer all the way to enterprise to industrial, and even in industrial, everything from manufacturing to transportation to agriculture, you name it. I look forward to sharing some of my insights with you today. I do want to call out that anything I share today is purely personal and my opinion and does not reflect anything of my past or current employer. Thank you.
Noted. Thank you, Anup. Thanks for joining us. So let's just jump right into it. We have about an hour and a half, and we can go as long as 2 hours. So we're gonna, like David said, we're going to divide today's discussion into 3 different topics. We're gonna start sort of with an overview for the market and the industry for people who are not so familiar with it, and then we're gonna go into some of the challenges, threats, and lastly, solutions. So why don't, Farid, why don't you start us off? What is the state of IoT, of the IoT industry today, and what primarily drives its growth?
Sure. Before that, I just want to just give very quick introduction of IoT from what I think in a very easy sentence. What I think is the IoT is connecting our physical world to basically the digital world, and help us to not only learn from the future, know the present, and also be able to predict and plan the future, that our optimum or better future, I would say. According to the latest study that came out, actually the number of the connected IoT devices this year is growing by 9%, and we will end up to have 12.3 billion global connected devices by end of the year, which I think our friends from Verizon know that better than me probably, that about more than 2 billion of that are the cellular IoT devices. And this forecasted to be by 2025, 27.1 billion connected device, which means 22% growth. So we understand a little bit the state of IoT devices in industry, how is important going forward. And all this coming together is considering still we have some big challenges like chip shortages that we're talking right now, and impact of supply chain by COVID-19, which is expected to be out there for next 2 weeks. From the market perspective, we expect it to be about 1 trillion by 2030, which last year I think we're somewhere around 400 billion, if I'm not mistaken. And this growth is coming to the certain level because of the development of wireless networking from the technology perspective, the emergence of the data advanced data analytics, and also the what is it called, the reduction of the cost for connected devices. And also we know from the industry and business perspective, business continuity and also having digital transformation, especially after COVID-19, is kind of expediting all of these requests, and everybody wants to make sure the remote operation, preventive maintenance, and all those kind of things will be in place before the next pandemic happens. So that would be the state, I would say.
Thank you, Farid. Anup, how far has industrial IoT come, and what is different about the industry today?
That's a great question, actually. Farid, you were absolutely right. What is IoT really about? Collecting data from physical objects and making some sense out of it. If you sort of take a step back and go back 50 years, 100 years, it's not really new that you are able to collect data from physical devices. I mean, industrial automation has existed for multiple decades right now, and actually one of my previous employers, Rockwell Automation, has been doing this for a number of decades. So what's really different now, right? I mean, industrial automation has existed for a number of decades, but now all of this hype in the last 5-10 years, or probably for the next 5-10 years, called industrial IoT. What is really different? The way I look at it is a few things have changed, and which sort of makes us shift from industrial automation to what we call as industrial IoT. One is connecting the unconnected, right? What I mean by that is there's always a limitation of what physical object, what controllers could be connected. And those could be because of wireless availability, wireline availability, connectivity speed, connectivity protocol. It could be any of that, but connecting the unconnected has changed. You could really connect a lot more today. Second is ability to do things remotely, right? And I'll talk to you about this as we go further in the panel, but COVID has really shown all of us why remote is so important, right? So the ability to not just be able to talk to the physical objects, but be able to sort of do it remotely. Then third one is, previously people were very happy doing it locally, right? I mean, bring the data from a physical object, have a computer right next to it, or probably have a PC right next to it, and be able to control back, have a closed loop. But now being able to collect the data across multiple different devices, multiple different plants, multiple different geos, and learn from one and apply it to the other is sort of new. And then finally, it's an IT-OT convergence, right? So previously, when you talk about industrial automation, it was really the OT guys who are responsible for this closed loop automation. But now IT is getting involved, IT tools are getting involved, IT is making it easy. Now, so when you apply all of these together, which is, connecting the unconnected, remote, cross-plant or cross-location analytics, IT-OT convergence, it increases both a top-line opportunity for some companies and a bottom-line efficiency for a few companies. And that's why industrial IoT comes in and is sort of different from sort of what we used to call as industrial automation.
Thank you, Anup. And Rajiv, maybe you can make it practical for us. What are some of the types of use cases you're using IoT for, and how are they providing value to Ford Motor Company?
Right. So I think there was a great lead in by Anup, because what we traditionally get measured on is how many parts can we make, are they good quality, and are they being made at a reasonable cost, right? So all the IIoT or IoT devices and data and such, unless we can make that better, it really doesn't help, right? So our use cases are broadly divided into maybe 4 categories, right? So top one is, I would say, quality, which essentially makes sure that we can use some of the connected vehicle data or connected sensor data to assess quality and have quicker feedback and quicker resolution of issues that pop up. So those are like a big piece of what we do at Ford. Second one would be maintenance. And maintenance is again tied to throughput. So we want to predict, equipment that is going to go down and have, remediation done off shift and so on, so it does not affect production. And then find the right balance between preventive maintenance and, and predictive maintenance and so on. Third one that is specific to maybe the automotive and could have analogies in other industries is what we call connected vehicle data, right? So as our vehicles are being built, how can we get the data now that the vehicles are sending through modems, right? It could be location data, it could be telematics data, it could be test data, and so on. And then finally, we also have a very labor-intensive sort of operation, right? So how do you use IIoT for for labor management, right? Connected devices, wearable devices, how does it help them? Also making sure that we have some of the feeds on how many people showed up, what is the best way of using them, and so on, right? So that's kind of how we are doing it, but it's all again measured, like I said in the beginning, by the same measures of quality and throughput and cost, essentially.
I think those are really interesting use cases, and thank you for sharing some of them with us. Erik, maybe you can tell us, what does the term massive IoT mean, and how is the IoT landscape expected to change looking forward? Maybe as a follow-up, you can also share with us a little bit about what Verizon is doing to address those developments generally across the board.
Absolutely, and as you've heard from my illustrious colleagues here, everybody's doing something different, right? There's industrial IoT plays an important role because of not just the bandwidth. Again, we're talking about, it seems that wireless is always talking about, hey, how can I go faster? How can I go more data? What can I do in lower latency times? Well, that's all important. There's also all of these things that need to be connected, solutions that need connectivity. What I like to say is making dumb things smart. No, I'm not talking about your coworkers. I'm talking about the devices that do very specific things. And at the end of the day, what we're worried about and what we really want to make sure that people understand is in the massive connectivity that needs to happen is that you need a network that will be able to provide that connectivity, not only for those high bandwidth, high throughput type solutions, but also for those devices that maybe need to wake up once a day and pass a little packet of information, but it's still critical for, let's say, a supply chain overall, right? So what you want to be paying very close attention to is what a network can bring, like Verizon can today, from a narrowband and broadband capacity and capability, in the sense that we're, for those that were paying attention back at Mobile World Congress a couple of weeks ago, one of our executives, Sampath, actually talked about how we launched our narrowband network and a narrowband offering where we're going to be having a solution that is a sub $4 hardware and a sub $1 per month usage fee to be able to get the data off the device. Now, again, it depends on what your use cases are, but now having a device that you can use to invest at that low of a price point, things start to change dramatically. We start to see those paradigm shifts that happen in this industry as a whole, because we start to see that this massive IoT that everybody has wanted and needed for so long, if it's just from something measuring a temperature to a vibration sensor, whatever it might be, now we have a network that gives you unparalleled coverage and in-building penetration, but also that is economical and will give you that connectivity at the point of need. So we get really excited when we start talking about these capabilities, because now we're opening doors to connectivity and solutions that were never open to us before. And that's where I know a number of you that are sitting on this panel discussion today are listening in thinking, hey, I've got the next killer idea. Phenomenal. That's what my team exists for, is to help develop and drive those solutions so we can actually find those next generation capabilities and move forward with whatever might be that's revolutionary in the massive IoT space.
That's really fascinating. Thank you for sharing a bit about that with us today, and I hope we get a little more into that later on. I wanted to ask Dr. Prasad, as head of Edge IoT strategy at Bosch Engineering, can you maybe give us a brief description of Edge technology for our audience today? What is it in just a few short sentences?
Okay, so it's important that we understand the journey of IoT. When we started using IoT, as many panelists very clearly said, we started connecting disconnected things and then started getting data from these devices, and then data is transported across multiple layers, and finally we park all these data to a place called as cloud. So that is how a typical IoT journey started. And today, where we stand, we are looking at a very strong cloud heavy kind of an architecture in IoT, which means to say, imagine I have an IoT system where I have hundreds of devices. At the end of the day, if I look at, say, 5 years of my IoT journey, I will end up with huge amount of data in my cloud. I will have plenty of data streamed in live through the networks of layers into my cloud. So what we are looking at is distribution of the load, which presently is very heavily concentrated in cloud, to multiple places across the layers of IoT. And that is what is called as edge. If I define edge, edge is one process where the load of the cloud, which is essentially around computational capability, is distributed across the multiple layers. And specifically, the load is actually given to devices where the data generation happens. The moment you actually park the analytics, which is presently at the cloud, at the device where the data is collected, you will bring a lot of transformational indices into the game. For example, you doesn't have to carry the entire data to the cloud. You doesn't have to store large chunks of data into the cloud. So the moment you do this kind of a transformational architectural change, for many of the applications, the data cost at the cloud will reduce. The network bandwidth, so people keep crying about the speed of the network. So they go for 5G, 6G. You don't have to have all these high-end infrastructure for many of the applications where the data collected can be analyzed and a small decision can be made at the edge, whereas the cloud is only used as a secondary a place where the decisioned data will be carried out to cloud, and further learnings can be actually done at the cloud. And once in a while, we sync up through FOTA to these dividers, and then the entire solution looks completely different. Today, the cloud heavy architecture, which customer is feeling little pain in terms of cost, in terms of security, in terms of latency. Latency is one of the critical factors where people are looking at edge heavy rather than a cloud heavy kind of an architecture. I will try to address some of the critical challenges which Bosch is addressing in this scenario, but edge is essentially bringing the load down from cloud to a place where the data is collected, which is at the customer side, and then giving the data analytics decisions at the site itself to the customer.
Yeah, I think that's a great way to describe it. Who do you think needs edge computation the most? And is now even the right time for customers to be adopting it?
So there are multiple applications which might not demand. See, the moment I say edge is future, it doesn't mean that cloud we will completely go away with. So cloud and edge always complement each other in several applications. Let's imagine one simple application like autonomous driving, right? A lot of people fascinate about Tesla cars, right? How can we actually realize a completely autonomous driving on the road? So there are plenty of sensors around the car. Car actually generates a lot of data, road data, neighboring cars data, terrain data, all these information. If we actually bank on cloud to steer the steering of the car, what if the cloud suddenly disappears? What if there is a huge congestion where I cannot get the decision from cloud to my steering? It is absolutely impossible to imagine such real-time applications driven by cloud decisions. And that is where a lot of these edge concepts comes into some niche applications where the computation is moved on to the place where the data is generated. For example, vehicle computers are really, really capable now. Why can't we use the data acquired from sensors around the car to get it into a vehicle computer where we have designed ECUs, engine control units, and the decision of moving the car, steering the car happens right there? Probably the impact of the cloud is reduced. And those are some of the applications which are really, really challenging for existing cloud native architectures.
Thank you, Dr. Prasad. Erik, maybe you can expand on all this for us. What other types of capabilities does IoT enable, specifically with 5G connectivity? And what role does cellular connectivity play in the proliferation of IoT?
Well, as you heard Dr. Guru talk about it, it's becoming it's like oxygen. All right, so it becomes so critical overall to the and having critical connectivity available, especially when you're talking edge solutions like we're discussing now, where we're really driving to again, where I talked earlier about the narrowband. Well, on the broadband side, it's just as valuable to have that data in a quick amount of time, but being able to have or flexible architecture to be able to deliver that data in a relatively short time from a latency perspective. So when you're trying to make, you have a big piece of industrial equipment that has to make a decision in a split second to change a direction or something that it's doing, or slow down or speed up, those milliseconds mean everything. And that's what we're very excited about in partnering with AWS and Microsoft Azure and others to be able to take that distributed architecture that you're seeing in the cloud and being able to make it available inside of the wireless network itself. So having a private network available to you, but also having private, what we call on-premise LTE and 5G networks, giving you latency in the sub 20 millisecond range of being able to move data through, but then having a unified capability as well from a coverage and end user solution perspective as well. So it gets really interesting, especially with when we're working with a lot of these edge carriers and edge solutions capable that are out there. So we can make sure that we give connectivity that's reliable, but also very fast and very capable as we start to move forward to some of these next generation real-time solutions that are out there.
Thank you. That was a great response. Rajiv, what are some of the technologies that you guys are currently deploying for your IoT use cases at Ford? And if I can ask, are you using off-the-shelf solutions or platforms?
Okay, so I'll answer the second part of your question first. So we started out with looking at some off-the-shelf platforms, but as we realized that there is a lot of limitations, those don't really live up to what we're looking for. So we were starting to, swap out components and eventually ended up with what we would call our own configuration of an IoT platform, right? So for the most part, I think there was talk of, getting data off of machines. So we have machine state data, we have machine, signals, we have sensor data, we have part traceability data. So all that we're actually publishing to message brokers, and we've got what we call a common data model, right, which essentially tells you about the taxonomy, because we have close to 1 million assets worldwide, right? And we need to know where the data came from. So that's important. And then each equipment would have a different kind of payload. So we have that also included in our common data model, which makes it easier to stream the data. And then again, some equipment, like the newer equipment, actually has smart PLCs and smart components that will actually stream out JSON type data, but older ones don't. So we need to take care of that problem. So, and then we're streaming the data either to, Hadoop, which is for, I want to say, cold storage. We're using some NoSQL databases, and also starting to use now the Google Cloud platform, right? So Ford's got a strategic alliance with Google. And then transformation. So again, using Spark, using a product called Alteryx for doing some transformations and so on. Now also getting into Google services for doing the same thing. And then dashboarding using, ClickView, ClickSense, Angular, sometimes Tableau. And then in a lot of cases, we're also feeding it back to our maintenance system, right, to generate maintenance work orders and so on, right? And we have not quite got to actually sending it back to the machines directly, but that's where we see going next time, right? Or going in the future, I should say. So that's kind of a high overview of what our, current IoT platform looks like.
Right, thank you. Circling back to Farid for a second, when we talk about IoT regulation, what happens to privacy and all of that, right?
Yes, this is actually very important topics, because usually what happens is with these IoT devices, we get so much caught up as a technology provider with the operations and what we provide as a capability and functionality to the customers that we forget about that. And another part of it is customers or end users come up and use these products for their convenience and what they need to do, or take advantage of it as much as possible for their future planning and everything, and connecting and digitalizing the whole physical factory that they have, or physical industry, or whatever industry that they have. They totally forget about the privacy. And two, privacy is important here. One, privacy is like, of course, the personal information that you have and tagged with all the information. And the second one is whatever is about your business. That's what's happening for industry or whatever identity that you have there collected. So these two parts is usually forgotten. And of course, in whatever device that you get, you usually get say, yes, I agree. You have a big list and you click on that. And you kind of give consent that they can do whatever they want to do with the devices. But the problem is those are not really with the consent, because you don't know the meaning of most of the terms and things that come up with that. You are dependent on them, because if you don't use their devices, basically if you say, no, I don't want, or I disagree with this, basically you cannot use that application or that work. Or a lot of problem, you're going to be locked with them, because from the regulation perspective, if you start working with them and then you find out their privacy has an issue, it's very costly for you to change, because there is no standardization behind it. So these are important parts. So in a nutshell, collection and use and disclose of IoT devices needs to be in a top priority for everybody who wants to use it. Doesn't matter personal information or the business information, because if you don't pay attention, it's very easy to lose your data, and you don't know what happens with those data and who lost it. Because in IoT, we're not talking about, I'm working with one vendor. There is let's say, just in a certain, for the sake of example, there is a camera collecting the data. There is a network that transferring the data. There is a cloud that's storing the data. There is some AI that doing the analyzation here. So who does what and why they're doing what with that data? Everybody has their hands on it. So this is very important from the regulation and from the push of the customer, because as we know right now, it still has not been regulated and has not been looked into it properly. So it has a lot of loose end. And what we have to do here as end users, my suggestion would be is, or from technology provider, we should not create a situation that I use privacy or have to choose between privacy or convenience and the technology that I'm using. I have to be able to enjoy all of them in one package of IoT.
Yeah, and we can probably talk about this topic for a good few hours.
I could talk about for hours, exactly. So
both from an ethical standpoint, yes, and from a security standpoint. But I'm going to move on to David now. So when we're discussing industrial IoT, we often hear about digital twins, and you mentioned a bit about it in your introduction. Maybe you can expand a bit on this right now, for us.
Sure. I love this concept of digital twins, and I came across it. It kind of reminds me like the first steps of us moving into the matrix at some point. So there's the the main definition of digital twin, where you're essentially, it's a virtual representation of of the physical world. So you have a physical device, and now you're simulating it on a computer for, say, monitoring it, or be able to model it, and it becomes a representation of it. It's actually kind of expanding a little bit, as well. It doesn't actually have to even be a physical asset. That physical asset could actually be purely digital. So you could have applications, blockchain applications, AI models that are changing, affecting behavior, the data itself, even the cloud environment. And you could actually start having even digital twins of digital assets as well. So it kind of expanded a little bit. So it's a representation of a digital or a physical object. The other thing I find interesting about this is it's starting to expand kind of the definition and capability of it. So if you think of it, typically digital twin is focused on one direction. Data is coming in about the object, you're simulating the object, understanding more what's going on, monitoring it. But there's more and more a two-way interaction here. So you have things around control, or even around security. And kind of, I'll give you an example from a security perspective. You could start to have a digital twin of something and add things about access control or data protection to it. So you could check a message coming in and see if it's valid, or if it has permission to even access the physical device in the first place. Or an outgoing message. Now you could even look at it, let's look at outgoing messages and check those. Does it have personal information that shouldn't be permitted? Or are there unexpected commands? Maybe there's a message to a pump that says turn it on and off too frequently. So you have a velocity check. So you could be stopping an attack from even occurring. So I think there's, in general, the general definition of you have a virtual representation of physical. I would expand that to being a digital world as well. And I would expand that we're actually expanding a broader set of capabilities, almost enhancing the capabilities of the things that you're representing as the same way. So hopefully that.
David,
yes.
You should not miss the example of Iron Man in the end game using digital twin. A lot of people can say.
Yes.
The most important example.
Reality is starting to merge. Fantasy world.
The Matrix, David. Now, I want to move on to our second topic for this evening, which it has to do with challenges and threats related to industrial IoT. And starting with Farid. Now, I know this is a big question, but maybe you can give us the top-down of some of the primary challenges IoT faces in regard to development and deployment, standardization, regulation, cybersecurity, etc.
I try to be as short as possible and just don't dive into any of the topics, but just give the top overview of it. I mean, from the development perspective, because as you know, if you want to talk about this, it's going to be another session, of course. Development is, you can look at it from the compatibility when you come to the technology provider, providing basically a platform to manage all of your devices all in one, basically. Being limited to the advancement of the innovative technology and also high final cost from the development perspective of IoT solutions would be, I think, my top choices. If we come to deployment, as you know, majority of the projects of IoT not meeting their objectives. I mean, there is something about 80% that's not meeting the objectives or failing total together. So that's one of the main one. And one of those is, of course, is ROI as well, because you don't have a good understanding of the requirements from your customers. High initial cost of ownership and maintenance for the customer, that's another issue. Connectivity issue, especially when we talk about wireless version of it, which is going to be the most popular one and needed one in the market, because when we come, the last one, which is I think 5G 16 release, was supposed to be with IoT with better latency and better connectivity, but it still has issues as far as the nature of radio frequency that we have, cybersecurity, and we just talked about it. It's a very important topic, especially after COVID-19, that became one of the major challenges here. And privacy, I just explained it. Scalability is another one, because you plan for something today with the infrastructure to put in place for IoT or industrial IoT, and tomorrow you add devices and suddenly your capacity is already full, and then you have to go back and change. It's very costly on the infrastructure, and complexity of integration with other systems that you have when you develop basically an IoT devices. We come to standardization and regulation. I already explained a little bit about the regulation, privacy, but the standardization is very important because it should not lock you into the certain brand or certain type of framework that you're working on. You should be able to pick and choose from any framework, any basically vendor that you have, and be able to have the best of the solution integrated together. And if there's no standardization and regulation, that's almost impossible. When we come to cybersecurity specifically, if we want to talk about it, there are a lot of things that we can touch point on it. Lack of secure boot process, exposed communication, lack of encryption, weak default password, malware, a lot of different things that I can, or legacy operating systems and such. I can go and talk about every single of them.
You know, and if we had the time, I would love to. We'll invite you back for another webinar, definitely. But I wanted to get to Rajiv. Rajiv, what are some of the challenges that you and your team have been facing at Ford when it comes to the development of your IoT use cases?
Right. So that's a great segue. So a great question, I should say. So so essentially, the first thing that a lot of the things we can do with the data is build these really cool looking visualizations, right, with all kinds of graphs and colors and all that, and people really get interested and are wowed by that, right? But that loses its luster pretty soon, right? Because they say, okay, this is great, but how does this help me? That rather just giving me sort of a nice thing to look at. So So then it moves from going from visualizing to predicting to prescriptive sort of, insights, right? So, so there we get into more the AI ML, right? Which is really what the promise is of having all this infrastructure, giving all this data. And there we struggle, especially in manufacturing, is lack of label data, right? So, so we do have a lot of data, but we don't have a lot of labels. So then we struggle with, having supervised machine learning cases. The other thing is a lot of what we call heavily unbalanced data, right? Because as I said before, quality is a big part of our use cases, and thankfully our quality defects are pretty low, right? So to actually use that data and generate some kind of insights, it becomes kind of difficult. And then a lot of our data comes from what we would call legacy systems, right? Because we have been collecting data for many, many, many years, right? It's not a recent thing, and putting them in databases. So missing or incomplete data where a casual user would say, well, we've got all this data we've been collecting for all these years, why can we not do something with it? But it's not the right kind of data, right? And then the other thing is we talked about, hundreds of or thousands of, or in our case, millions of assets. And do we build individual models for each and every one of them, or can we go to some kind of a federated approach, right, where we're using, the commonality amongst models and such? So those are, I think, some of the challenges that we are facing. And in order to actually provide, a model that has got fairly good accuracy, you got to wade through all these and identify the right ones, and then also manage some of the expectations as to what this is going to do, right? So hopefully that gives you a little insight into the question. Thank you.
Definitely, and I think managing expectations is definitely a big part of that, especially with stakeholders. When you show them a shiny graph. Anup, is now the right time to solve these challenges?
Well, we've been talking about IoT for how many years, right? Probably for the last decade. There's been so much hype around IoT. In fact, like 3 years back, it was at the very peak of the Gartner's hype chart. And that's in a good and bad way, right? I mean, if you look at it, sometimes unrealistic expectations were set of how much of billions of dollars is going to come from IoT. And frankly, if you go ask a lot of the companies, are you really realizing that much dollars in revenues? Probably it's not lived up to its expectations. And there's probably a couple of reasons. Very rarely do you have technological advancement and business need intersect, right? I mean, I think IoT had a lot of technological advancement over the last few years, and that's why we are where we are. And Dr. Guru spoke about it, Erik spoke about it from a network point of view, edge point of view. So we have made a lot of improvements. But I think the key was the business need intersecting. And I think right now we are at the crossroad where the business and technology is starting to intersect. Look at an example of supply chain issues, right? I think David mentioned it in his earlier remarks. That's a great example of a business need that's emerged in the last 12 months because of the pandemic that needs to be sort of solved, and that could be through IoT. Look at the retail experience, which is the new customer experience and omni-channel. When you go into a mall today, it's going to be a very different experience with AR, VR into it than you had before. Now, that's a new use case that's emerged. Now you look at, like medical, or you look at autonomous driving that, again, Dr. Guru spoke about. These are net new use cases that did not even exist before that are sort of emerged today. So now these new use cases that have emerged, along with the technological advancement that we have made, I think makes it approximately the right time to hopefully hit that intersections. And I, as much as you all are really, hoping and cheering for IoT to sort of take off, and this is the right time for it.
Yeah, I'm hearing the enthusiasm in your voice, and I think many people are nodding their head along with you. Farid, what are the most important interoperability challenges of IoT when it comes to industry-wide adoption?
Right. So I want to actually touch point on certain things that, again, is mostly forgotten on certain discussion and we discuss. One of the important part is right now we're talking about connected world. When we talk about IoT, of course, we have a smart city, we have a smart home. Everywhere we go, everything is connected. So the one question is, do we have enough pipeline to transfer this data? The amount of the data that we're going to transfer, and just consider your phone right now. 10 years ago, without a smartphone, how much data you were transferring from your device? And now with all this social media, putting all these things on the cloud and Instagram videos and a lot of different things, how much data you're transferring right now. Do we have enough data pipeline? Right now, one of the most important issue or question is, which actually most of the government looking at, is because the radio frequencies are already overwhelmed and licensed for even like over licensed, I would say, and there is not enough pipeline to make that connected world happen. So that's one thing that we have to look into it. And there's a lot of fun for researchers for wireless networking. And I talk about that one of the new technologies that's coming in place considered, and actually I had another speech about this, about like 6G putting the 5G together plus Li-Fi, what we call it, Wi-Fi and light-based communication, which is free and you don't need the license. That's one of the solutions. Another one is security and safety, but I'm not looking at the same cybersecurity that we're talking about, but the nature of the radio frequency that we're using is, for example, you're sitting at your house or your apartment right now and watching us. If you want to connect to Wi-Fi, you see like 10, 20 Wi-Fi, which is from your neighbors, from stores, from everywhere around you. And it's easy, password protected. How are you going to do that? Of course, there are a lot of cybersecurity measures, but it's still, you have to look at from the nature part of it, that again, that will be another issue or interoperability challenges. And especially when we come to the industry or when we come to the sensitive places like nuclear facilities, or we're coming to, let's say, army, military, those kind of stuff, it's very easy to jam radio frequency and take over that connections and communications, not again by cybersecurity things, but by jamming. And just imagine a connected vehicle or autonomous vehicle have an electromagnetic field around it in a way that it's jammed with the signal. In New York, when you don't have GPS available, see what happens. You create a disaster. From the safety perspective, same thing. Some of these technology that we're using having bad impact on the body, and a lot of people raising, or doctors raising a lot of concern about that. Another thing which I already talked about, it do not touch base on it too much, is scalability, because again, we need to make sure we be able to cover all of this when we grow into our industry. And last thing, but not least, which is EMI, electromagnetic interference. Right now, using or having IoT devices, especially from the connectivity perspective, using radio frequency has a lot of issue in industry, because there are a lot of electromagnetic field which doesn't let your devices work properly. In another hand, you go to places like, let's say, MRI room in hospital. You are not allowed to use any wireless networking there. So you cannot connect your devices with the wireless network. So how you resolve that? And again, that's why we come up with some innovative technology, things like that. Like for example, I made an example like Li-Fi or light-based communication is coming to help 5G and radio frequency right now as next generation of the communication to be able to solve some of these interoperability challenges.
Thank you, Farid. We're coming up on an hour right now. Is it okay for you guys to go another hour, or should we try to finish the discussion and leave time for a short Q&A? What works for you guys?
Yeah, I mean, maybe 30 minutes, an hour might be long, but if there's tons of questions, then we'll just keep, we'll go from there.
Yeah, so let's try to get through this to the rest of this discussion. I mean, super interesting. I don't want it to end, of course, but yeah, we have a lot to cover.
We could go on for 6 hours.
We could go on for a long time. I don't know if Zoom even has a 6-hour meeting setting, but Erik, we often hear about IoT in an almost sci-fi context, right? Like robots and drones. But are these really realistic applications in those spaces? And I mean, are there realistic applications in those spaces, such as with autonomous cars? We spoke about it briefly, or last mile delivery.
Absolutely, and that's where we really shine. I'll be honest with you. You're seeing some really intriguing use cases that start to kick off, especially in the V2X, the vehicle to many communications protocols. And in fact, Verizon is key in helping push forward the cellular V2X solution, where you start to take the roadside unit type of connectivity that needs to be there, broadcasting if it be a tower on the side of the road that's giving information. We found that when we turn the vehicle into a broadcasting unit that actually gives that starts to be a little bit more reliable and starts to give a lot more relevant information. So we start to see some really intriguing capabilities, especially when we start to do those capabilities down the road. And again, what the nice thing is that Verizon already has that strong foundational network that's always existed in our long-term evolution, 4th generation network that we're building on top of with our 5th generation mid-band and millimeter wave networks as well, where we're going to be able to have what I like to call the good, better, best user experience, right? Especially for the last mile delivery solutions where they need to have connectivity. Again, we want to make sure that you're having the autonomous vehicles doing what they're supposed to, but as more and more of these types of vehicles and transportation methods start to clog our streets and our sidewalks, we want to make sure that everybody's safe and that they're all talking to each other reliably, but also that we're giving them connectivity that can shift up and shift down depending upon what's needed. So if you're having that last mile delivery and it happens to hit a road cone that's right in its way, rather than shutting down and waiting for somebody to get to it, we could turn on the capability of onboard cameras and have somebody remote pilot it and teach it what to do and be able to have those capabilities. And again, you need a robust network with high bandwidth, high availability and capable networks to be able to do those kinds of things. And that's what Verizon's doing right now. And we're looking to pilot on these next generation solutions down the road where you have those capabilities for the autonomous vehicles of tomorrow and being able to give them connectivity and a good foundational capabilities to really move forward on that from here on out.
Definitely. Rajiv, we spoke about some key challenges already. You also spoke about some of the challenges you and your team faced when deploying your use cases, but are there any that other ones that need to be considered, which we haven't touched on when it comes to deploying IoT solutions?
Right. So I think, as I said before, right, there's a lot of labor-intensive operations within automotive manufacturing, and people are really tasked to, do certain things. So if you've watched the movie Modern Times, you can see the assembly line, right, where there's no time. So essentially, it's like we've got to figure out, is this solution we're providing, is that going to be integrated in an existing business process, right? So that's the first thing that we always look at, because otherwise it's just another shiny object which may or may not get used, right? And then what happens once you actually get to that challenge of having people actually adopt it, excuse me, then you got to make sure that it is supported, right? What happens if it goes down, right? So that's the other thing. And then the other thing is it, a standalone thing, or is it part of some kind of portal, right? Because the reason a smartphone is so popular is I got one device that can do everything. It can do my banking, it can do my social media feeds, it can do my, email checking, it can give me directions, I can talk if people still do that on the phone, right? And all that, right? So it's the same thing, is how do you integrate all this where you're providing a single interface to whoever is going to be using your particular, application. So those are some of the things that we consider when we deploy, and obviously the successful ones kind of hit, all those bullets, and that's what we try to strive for, but it doesn't always become possible, right? But something to be considered right in the beginning.
Thanks, Rajiv. And Dr. Prasad, we spoke a little bit already about edge computing. You gave us an overview. You mentioned, some industries it's related to. I'm wondering, what are some of the present challenges that are faced by organizations that are considering deployment of edge technology?
Okay, so there are a lot of people who are there as ambassadors of typical IoT. So let me put it from a different perspective. Today, people are trying AI machine learning models on typical IoT applications, but there are a lot of challenges in deploying AI and machine learning models in a standard IoT stack itself, because AI models are very, very power hungry, very, very memory hungry. It's not easy to deploy such models on edge servers. It's actually very, very challenging. So people talk about deep learning algorithms to actually deploy and solve your problems. But can somebody explain what does deep learning algorithm do to devise those inferences? Nobody knows, because it has a lot of neural networks which tries to take its own decisions. So explainability of these AI is a very big question in a standard IoT stack itself. But when it comes to AI deployment in edge kind of a scenario, it becomes a mammoth challenge. because you hardly have any processing capability. You hardly have any memory to store your data. Now, how will you actually envision an AI model to come and sit on an edge device, which is a constrained computing environment, and then still help you, giving you inferences? This is one. Second, there are a lot of things on security. In fact, David touched upon security at a very high level. So let me tell you, the moment security gets connected with edge, so it becomes a serious challenge. Example, security of the data. What we are doing today is the data is collected at the edge by devices, sensors, data is straight away transported to the cloud. But whereas the data here gets analyzed at the edge. So the security of data becomes very, very key. Second, security of the AI model. Now, what we are trying to envision is you build a lot of these smart, intelligent, artificially driving models, which are self-learning models, deployed at the servers, deployed at the devices at the customer side. Now, all your effort which you have put in for 5-6 years in training a model and devising a very accurate inference gets told like this, because you don't have any control on somebody stealing your device. The moment the device is stolen, your model goes away. The entire training set, the model architecture, that the multiple tires that you have used for clustering, everything goes. So security, scalability, and the last but not least is deployment of such models at edge becomes key challenge.
So is the market ready for reliable, secure and safe edge deployment?
So somebody actually shouted very clearly that we have not even harnessed complete potential of IoT. But Bosch, as a very strong technical company, so we are trying to address these in two domains. One, somebody who is actually solutioning edge ecosystem should have a very strong embedded and hardware knowledge, and that is where Bosch comes into game. Second, these hardware systems have to be very well tied up with a middleware and a firmware on top of it. The moment you actually collaborate knowledge of hardware embedded onto an IoT system, then the actual convergence of a value coming out from an IoT system. I still, cross my fingers. There is yet to actually see quite a value from a standard IoT. Edge is too far.
Thank you, Dr. Erik, what about verticals with less consumer visibility, like manufacturing, heavy machinery, real estate? What are some of the applications and considerations of IoT when it comes to those industries?
It gets interesting because, again, from a connectivity standpoint, things get really intriguing when going back to my earlier comment where connectivity plays a role in so many different ways. And it's a matter of being able to know that sometimes it's the non-visible data, right? So we've talked about, temperature and vibration, the typical things that are out there on top of, hey, I need to know what's inside that mini computer that's inside whatever that end user device is I need to have communications for. But what's been intriguing is some of the industries we've been working with, like heavy machinery and others, where they want to do remote driving solutions or the things they want to know a lot more than just, hey, if I push forward on the joystick, will the vehicle go forward, right? It's funny because one of the interesting conversations I've had with a very large heavy equipment manufacturer is that their drivers learn how to drive by the way the vehicle feels. So when they're sitting in the seat, they're actually driving that vehicle and knowing if that blade is biting into the dirt or not by how the vehicle's vibrating. Well, that doesn't really translate well if you're sitting in a remote driving seat 1,000 miles away. So as a part of that, we need to be able to provide, as part of the wireless connectivity to them, that force feedback capability that actually provides the information to know, hey, this is how the vehicle's actually feeling as they're driving it. So while that's a unique case, that really shows to me that you need to have a robust capability from a wireless connectivity standpoint, because it's not just data sometimes. Sometimes it's atmospheric. Sometimes it's relational information that's around you in that specific in the thing that needs to be brought into consideration. And that we have found some really intriguing capabilities. But again, having the bandwidth and capacity to be able to do that is key, which Verizon is very well suited and capable of doing so.
Very fascinating. Thank you. Anup, so many projects get stuck at the pilot phase. What are some of the bottlenecks that exist when it comes to scaling industrial IoT solutions?
In my experience working with multiple different customers across multiple different industries, from manufacturing to transportation to oil and gas and mining, the two things is really what customers have told me. It's complexity and cost. Okay, that really stand out. But actually, that's not the real reason. If you really peel out why is it complex? And actually, I had this unique advantage of building IoT solutions both for consumer world and for the industrial world. I'll tell you, the complexity is there not because of the technology itself. I mean, I know Dr. Guru might disagree with me because he just said we are not ready there. There's a lot of technological advancement that still needs to happen. But we have come a long way. I think we have enough of a technology to add value. But how we deliver the technology is where I think there is a lot of problem. If you think about it in the consumer world, you don't go pitch to a consumer, here is analytics, here is database, here is visualization, here is edge, here is cloud, here is sensor. You don't do that. No consumer is going to buy a solution if you do it. You just send them something and said, hey, plug it in and boom, open an app, it works. Try doing that in the manufacturing world. It's like a 12 months, 18 months, 24 months life cycle. I think Rajiv just mentioned how he couldn't find off-the-shelf solution. He had to put a technology team and he had to build his own IoT solution, right? If every tier one company like that starts building their own IoT solution, it's a long drawn. And tier two, tier threes are never even going to get there. Right? So I think what is really missing is the complex value chain needs to evolve into something of a more simple, vertically integrated and end-to-end offering that is given to an enterprise or a customers that's easy to consume, delivered more on an outcome basis as a service, as compared to here is a jargon of technology and here is components of technology for you to deal with. I think that's really the real reason of complexity, but what we really get heard is complexity and cost.
Yeah, it'd be interesting to see if that needs to be industry focused. David, what are some of well, we spoke about a few of the cybersecurity challenges. Maybe you can talk about any of them that weren't mentioned until now. And there's a long list. So
yeah, I'll keep it brief and just fill in kind of some of the things because people definitely did bring up some of the items. You know, one at a high level, and then just a couple of examples is one, I think what people don't realize all the time is the magnitude. Literally just read something from Gartner the other day that 30% of the critical infrastructure organizations are going to have a breach by 2025, which is a phenomenal thing, just a huge surge in the number of cyber attacks that are going on. And a lot of them are going to be, you know, life-endangering thing. You know, I mean, talked about the Florida water example before. Somebody corrected me about the Colonial Pipeline, said that was more of an IT issue than an attack. But there's more than enough examples here. And I think if I had to summarize that, the issue around cybersecurity is that it's actually being weaponized. You know, it's not just that it's being disruptive, but it's also being weaponized. Personally, if you want to attack a country, you're better off with cybersecurity than you are with missiles at this point. It would shut us down instantly. Funny thing, I heard one security expert, no names mentioned, who told me, look, breaking into an Iranian nuclear power plant is easy. Getting into a Swiss bank is another story. And I say that because the critical infrastructure in those areas are much more like nuclear power plants than they are like getting into banks. And I think there's a lot of work to do in those areas. Some of the things that, you know, I think are, you know, Dr. Prasad say about protecting even AI. You have to protect the model and the data. And especially if you want to start collaborating, how do you protect the privacy of all that information that's coming in from multiple places? You know, the automotive example is always easy because people understand it. Somebody's about to crash. You change the model that says, hey, the accident's 10 feet away. Only steer clear if it's, you know, 100 feet away and nothing happens. Or you change the data to say, hey, it actually is 100 feet away. It's not 10. There are so many avenues to attack over there. The physical location. I think Dr. Prasad mentioned that as well. You're not in a traditional secure data center. So somebody can literally, you have two mechanisms. You almost need a secure data center in a box because you have two issues. you have the tamper resistance. Somebody could go and physically tamper with the box or physically take it away and do something. And you also have all those security mechanisms, the 50, 100 different things you have built up in a secure data center don't exist in a lot of places when you're just dropping them into an industrial plant, dropping them into a sports stadium, putting them on a 5G access tower for computing power. They don't exist, you know. So how do you resolve all of that? And just as an aside, Guru, I'd love to talk to you afterwards, because that is actually what our solution does. So I should probably hire you as a salesperson instead of talk to you otherwise. But it does, and even distributing software to 1,000 distributed edge endpoints, how do you do that securely and stuff? And those are really, you know, huge challenges around there. So those are some of the things. I'll keep it short and only for the sake of time, and we did, you know, cover some of these things.
Yeah, thanks, David. So last but not least, we don't have a lot of time left, but I'd like to get into some questions from our third topic related to approaches and trends in industrial IoT. Maybe I'll throw out some questions, and yeah, it would be more of a fireside chat. Just feel free to respond and yeah, and to jump in. I'll start off with Rajiv. What are some of the key IoT challenges that you anticipate arriving in the future?
So I think we've all talked about scalability, right? So that is a huge one, right? So we've got a lot of assets, and with a lot of data coming in, how do you scale everything up, especially if you're talking about sending everything to the cloud, right? And not so much doing things at the edge. So that is one. And then how do you action all the insights that we get, right? So it's akin to your notifications, right? Everybody wants you to sort of turn on that bell icon, click on the bell icon, and then turn on the notifications, and your phone is continuously, you know, beeping or ringing or vibrating or whatever, right? So that's a challenge. So I typically turn those off, because if I want to look at something, I'll go look at it, right? I don't want you to keep telling me that something new happened here, right? So that's how do you find that balance over there? And then the other thing is, like, we've so far not gone and automatically run ML models and then given, you know, instructions to a machine to make changes, right? We still have the human in the loop over there. So we've got to, I mean, and if we have to get to there, how do you actually make sure that you have a very robust system, right? And then I think finally the cost benefit analysis, right? Like I always say, I mean, at the end of the day, we are in the business of making cars that are high quality and low cost, right? So anything that, you know, helps us do that, we are willing to spend the money on. But anything that is just another shiny object that doesn't satisfy that goal, how do you justify something like that, right? So those are some of the challenges I see in the future, right? Because it's now slowly getting from a push system to a pull system. But again, you could, you know, if you don't do it correctly, you could end up with sort of getting a black eye, and pretty much, you know, nobody wants to use it anymore, right? So that's really where I see it's going.
Yeah, I see Dr. Prasad nodding his head. Do you have something that you want to add to that?
I think it's very relevant that I quote one very, very challenging statement or a scenario a lot of people actually can ponder on. So imagine we actually look at a lot of robots working on its own in industrial shop floor. Can somebody imagine how does this action happen? Say one robot taking a windshield and putting it onto a car, the other robot keeps working on the wheels, the other robot keeps sweeping the floor. Can somebody imagine the technical stack between this operation? First thing, the data needs to be collected. The moment somebody was talking, the moment one step from a robot has to happen, there are a lot of decisions actually have to digest, and then the step happens from the robot. Now, one thing is you'll have to collect data from a lot of sensors of the robots and then take it to a server, get some decisions, and then act. This is one. Second, can we look at some collaborative robots? We talk about what is called as collaborative intelligence, which means to say, I don't depend on cloud now, because the entire data which is actually required to do some actions lies with me. So I collect this data. I will ensure that the data collected by me is circulated to all my fellow mates in the shop floor, and I do the same thing. I collect data from them, and what is called as collaborative intelligence. So I look at developing a collaborative intelligence layer where each one of them have their own job. So if there is an object which has to be automatically picked up, if you have 200 robots in a shop floor, who are the 2 robots which will go and pick? Shortest path, somebody who has enough battery, somebody who has enough strength. So there has to be a tendering happening between the robots. So you have a lot of intelligence which needs to go into a shop floor, like an industrial IoT kind of a system, where the decisions has to be taken at the edge, because the data is available at the edge, which has serious impact rather than going to the cloud.
Thank you, Dr. Prasad. I'm just going to open this question up to the panel. Anyone can feel free to answer. What does the future hold for IoT from both a technological and financial standpoint?
I can jump in, certainly there. I think from a technological point, I think I already raised my perspective of complexity, right? The value chain will have to get simpler. There has to be more vertical integration to offer solutions to customers. The things have to be offered as a service and outcome based. And finally, we will see, some bigger players entering the market who will offer it as a service to the enterprise. So I think those would be sort of my 4 takeaways of how this whole thing would scale and become realistic for people.
Does anyone want to add to that? If not, I'll move on to maybe some Q&A, which we have here. According to published information, a large percent of IoT projects do not deliver the expected benefits. Why is that?
I can jump on that. So basically, the first issue, that was one of the things actually I raised as well. Actually, that number is 80% is with the latest study. And the most reason is, the top reason is that the vendor usually doesn't understand properly the requirement and doesn't manage the expectation of the customer. Is usually we are hung up on the marketing name or marketing terms that we have, IoT, industrial IoT, 5G, all these kind of things, AI. But when we come to reality, for example, right now we all hear about 5G here, 5G there, but that's not the reality of the 5G. 5G is not here and there. It's just a term that all of these companies and broadband companies using to the first for the marketing tool, and the second, that's what happens. So in the most of the projects, the understanding of the requirement and mapping it properly to what will become or form a solution design is where we're lacking. And then we're over-promising what the solution can do for the customer. And then we are not putting a full package together, because IoT is good. Yes, we can do connected devices, but if there is no proper AI data analysis there, then you're failing right there. If you do not know, it's not all about the collecting the data, but what you're going to do with the data. What do you expect from the data? What is going to happen after I get the data? And then how can I use that and translate it to some return on my investment to be able to come up with some changes? Like digital twin is a very good example of that, right? To come up with some prediction, to come some of the future changes or the best optimized planning. If you don't do that, if you don't have that mapping properly, which is mostly where we're lacking, then that's where you're failing most of the time.
So I'd like to add to that, right? So I think what I'm generally sort of observing is that people like data scientists, right? I mean, a lot of companies are hiring data scientists, and all these data scientists have gone to, schools, and they have learned through Coursera and such, right? And they all want to apply these fancy models, right? Like, I want to apply deep learning with so many layers and blah, 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 right? But on the other hand, some of the business problems is, at least in manufacturing we deal with, don't require that kind of rigor, really. So how to find that right balance on providing something with value that is simple enough that it can be explained. I think somebody else mentioned that also, right? So that's one of the challenges, because the unrealistic expectations from the users, and then the I want to say the desire from the providers to actually make it as sophisticated as they possibly can, right? So how do you find that right balance? So that sometimes is a challenge, right? So that leads to a lot of failures, because is what I have observed in the few years I've been involved in this area.
What impact has COVID-19 had on industrial IoT technology before, during, after? the pandemic?
Maybe I'll take
I can
this.
maybe answer. Oh, sorry, go ahead, Mr. Guru.
Yeah, okay. So what we have actually visualized from last 2 years is trust. The moment actually COVID struck us, we never thought that somebody can actually remotely monitor their farm, not even visiting there once a month. Something which pre-COVID people have not even thought about it. So now it has become a reality. I'll give you a simple example. An agriculture farm needs to be well maintained in terms of light, in terms of humidity to the soil, and we can actually do all of them from a remote place. You have soil sensor, you have light sensor, you have humidity sensor, which can actually give you real-time data from the farm. And what you do out of it, get this data to a simple cloud, which is available free, and then run some high-level thumb rules. You don't need a AI model to actually do this. If the temperature goes down, you do this action. If the soil moisture goes down, you actually start the pump. What COVID has actually done to all of us is to actually trust the data coming from these sensors. And what is required to actually go beyond this COVID time is to ensure that the devices which collect the data, somebody was actually highlighting, have we really realized the value that a customer wants from IoT system? We are too far. The reason being, the devices which are actually collecting this data needs to be smarter. People say garbage into the model is garbage out. If you don't give a quality data to any super duper model, you will never ever get a quality output from it. The simplest answer is start from the root of the problem. You have to acquire quality data from the devices where the sensors have to be smarter, and ensure that the data which actually is generated at the device needs to be well utilized so that you bring right actions to the team.
Anup?
All of us have started working from home. The fact that we are all doing this virtual today and not sitting in a physical room is what pandemic has taught all of us. And that's exactly what has happened in the manufacturing world. People have realized that they need to get into remote operations, right? So if there's only one word I want the audience to take away in terms of what has COVID taught us and what changes need to happen, is being able to do things remotely, right? And that is sort of the definition of why IoT exists. And I'm happy that's why pandemic sort of accelerated IoT to some extent.
So we have one
Rajiv,
final
you have
question.
one more Omicron at you. COVID has gone off. Omicron is stuck.
We have one final question here, and then we'll wrap things up. One of our attendees is asking, is air gapping a thing in IoT?
Sorry, we couldn't hear it.
Hastings is asking, is air gaping, am I pronouncing it right? Air gaping?
Air gapping. No, you said it
gapping.
right. You said it the right
time. Right. Okay. A thing within IoT industry. Yeah.
Well, again, when you look at the definition of air gapping, what you're doing is you're isolating systems or capabilities so they're isolated in and of themselves. If you do your network, if you have a secure network, if you have a secure platform, if you have a secure SIM, then the reason for air gapping goes away, right? So what you want to do is, as some of the members of this panel have already mentioned, you want to make sure that you have security that is talking to itself, in the sense that, okay, when I leave this data and it leaves, there's never a trusted entity, right? So the device, even though the device is sending messaging up into your cloud, you need to make sure that there's a capability that you know that, hey, that endpoint hasn't been messed with, or that hasn't been modified, and that data stream isn't changing in any way, shape, or form. And then there's a lot of other layers beyond that. It's kind of layers of an onion, as any good security expert will tell you. But air gapping, not as much, just because, again, used more in secure communications, where you have to put, where you're physically putting air in between things to make sure it's secure. So as long as you got the security at a highest level, that is not as a ironclad requirement overall.
Yeah.
I have one. Mm-hmm.
I should even say, you got to be careful even with air gapping. I've seen places where air gapping actually causes more problems even than it helps. people find ways of getting around it. If they have to transfer something, they'll put in a USB drive or something to move data, and you're actually adding even more exposures than if you actually use a secure network. And there are solutions that you can actually make the network secure. So it always sounds secure because you're air gap, but it actually may even be increasing your exposure.
Interesting.
Sneaker net, we love it.
Yeah.
Guys, we have a slew of questions that just came in. I'm gonna throw one more at you, I promise, and then we'll wrap up. What are some recommendations on how to upscale our C-suite in industrial IoT?
I would say start with asking them what problems they want to solve, right? I mean, can they articulate those problems in terms of, okay, why do they, just knowing about IoT without actually having applications is really hard, right? So I think that would be what I would recommend, is start with asking, what do you hope to gain from this, and then sort of lead from that and customize the solution to that problem that they're trying to solve, right? I mean, just as a learning exercise, if you will.
Okay, well, with that, I think we'll wrap things up. Thank you, everyone, for your vast insights and for really wonderful discussions. We could talk for hours on this, like David said, and I'm really glad that we got the time to discuss these topics today because they're super relevant, they're super important, and I think it was I want to say Erik who said that we have to solve these challenges now, or Anup, was it Anup? Erik. Okay, and I'd hope to have more discussions like these with you guys in the future. Yeah, and I wanted to thank our panelists. Thank you, Erik, Varney. Thank you, Farid, Bichareh. Thank you, Rajiv, Kalamdani, Dr. Prasad, and Anup, Mohan. And thank you to all our attendees as well who are joining us today from home. We hope that you stay up to date on Hub Security's events. You can follow us on Twitter. We're also on LinkedIn. And to get in touch with any of today's panelists, you can reach out to them directly. All of today's attendees will be receiving an email in the coming days with contact information of each of our panelists. So don't be afraid to drop them a line if you have any questions about anything that we discussed today. And I hope everyone is staying safe and healthy, and hope to see you guys soon.
Thank
Thank you,
you.
everybody.
Thank you.
Stay safe.
Thank you very much.
Take care.